Hello, Cassandra and Shreya right there. Good to see you here. What questions are there? It is the morning office hours, and we are waking up MuBot right here. Hope we don't have any lag. MuBot has updates. Stream OBS has updates. I'm too afraid to update stuff lest something break. Maybe I'll try to update stuff this weekend, but watch me update something and something breaks, and it's like, well, now I'm fixing things. You update something on a computer, and it's just like, you never know what's going to happen. You go to Windows 11, things go crazy. I think MuBot's awake. Let's test him out right here. MuBot, are you awake? He says, yes, I am, with those 100 points right there. Can you go over the side-by-side box plots using Graph Builder for the Visualization 3 bivariate visuals? Of course. More than happy to, Cassandra. Thank you for the questions. Can we go over the question about was the probability of student being born in TN on the Canvas content quiz yesterday? Yeah, let's do that one too, since we got that. Here we go. Let me take some notes. Let me get the notepad out. Okay. So we got here Visualization 3 help, Stat Tool 1. Put those questions in the chat. And then we got here Canvas content. Let me see right here. Do that. Stat Tool 1, Canvas content, born in TN. There we go. We got some good stuff. Can we do the Chapter 4 quiz question about cumulative frequency horse racing? Of course. Stat Tool 1, My Pearson. Keep those questions coming. We are lining up the questions, or we'll say Chapter 4. That's the OGIV. Chapter 4 quiz, horse racing. Okay, we got that one. Thank you so much, Mary Catherine, right there. I'll throw out some more points. Another 100 points. Everyone giving some great questions to start us off right here. So let me go ahead. A little chill music right here while we get started. I hit 2 songs. We only need 1 song. We don't need 2 songs. I'm going to hit my screen. Watch me disconnect a wire. That'd be very bad. Okay, let's get the Canvas content up and going right now. And drop those questions in the chat if you have them. We already got a few questions. So remember, if you join at any time, ask a question. I'll put it in the list of questions we're doing. So even if we're working on a question, just for those here right now, if you ever join a stream and we're working on a question and you're like, ooh, I need help with this, just drop it in there. Say, hey, Brian, can you work this question? Even if I'm working on a question, because that's the number one way to make sure your question gets asked is then we'll do it. We'll put it on the list and we'll work on it. So if you join at any time, jump in with those questions. So let's go check out the visualization number 3 right here. Let's go take a timestamp on this so we can easily add these to the video later. Here we go. Stat Tool 1, visualization 3. Let's do this. Okay, so visualization 3 right here is bivariate visuals. When it comes to bivariate visuals, we're talking about 2 variables at one time. You're not just doing 1, you're doing 2. So we got here a Stats 1 survey data set. Takes a random sample of 400 plus the last 2 of your UTID. So you should have something like 423 or 458, 4 something. Make sure it's 4 something. And we're going to put this in a document. Now, one thing I always want to point out is when you're looking at, if you get the points, go down here to the things. There's lots to look at, but you really just want to read this. Mosaic plot of a particular variable with total percent, column percent removed from the condition table, along with a short write-up about the association between the 2 variables using information from the graphic. So that's very important. Mosaic plot created with all the requirements of the instructions. Write-ups includes numeric information, so make sure to do that. You can see where you'll lose points. So make sure to read these right here and be like, did I do the number 1 things? Read the description and then read the number 1 thing. That's the way to ace the questions, is like, be like, my visualization was created with all the required display options, includes accurate write-up. So then read this right here about the write-up. Good stuff right there. So make sure to follow those, and this walks you through it. Let's get the data. Now, we're not going to do the exact same thing at once. Now, make sure it opens in Jump. Should be good right here. Opening in Jump. There we go. So the first one is a Mosaic plot. Does anyone know what kind of variables Mosaic plots work with? When we do a Mosaic plot, who knows in the chat for another 100 points right here, what kind of data does Mosaic plots work with? Mosaic plots visualize what kind of data? Who knows in the chat right there? This is a very important thing to know and understand. I would copy this down. I'd practice writing it down. I know it takes a while to write this all down, but how do you make sure your random sample files? Oh, through the guesswork. Yeah. Mary Catherine's right. Categorical, categorical. So we're going to show this right here. Maria, good question. We're going to make sure it has it, and it is categorical, categorical. I'm blocking it in this moment. There's where the Mosaic plot is with categorical Y, categorical X. Great job, Maria and Mary Catherine right there. So that is correct. And here's how to take the random sample. To take a random sample, go to Tables, and then go to Subset. When you go to Subset, make sure to type in 4 plus the last 2 of your UTID. Make sure it's your UTID, not the one I'm entering here, but 4 plus the last 2 of your UTID. You can click the button if you want. Actually works if you don't click it too. But you want to click OK. Now you'll notice right here, this is 400 plus the last two of your UTID. You can go right here and close out of this one because you won't be using it. And you could even go to File, Save As, and call this something like My Random Sample. So make sure go to Tables, Subset, so Table Subset, and then take 4 plus the last two of your UTID right here. I've already subsetted it, so we're good. And then once you take the subset, make sure it's using this right here. Does that make sense, Maria, right there? So make sure it has that. No, so we might hit a lag burst right there. I saw the disconnect, reconnect. I know it's been happening more randomly lately. Oh yeah, just close out of the other data set. Once you get this done, close out the other data set. Sorry, there might be a lag burst. We'll always refresh if we ever hit a lag burst, but I saw a disconnect in the bottom right corner right there, which I can tell when it's sometimes me. Sometimes it's YouTube Wi-Fi, sometimes it's me, sometimes it's YouTube. You never know online here on Stat 201. So, but we're all good. We're all good. So now that we have our random sample, we got the first part done. Using the random data set, submit a Word doc, include the write-ups. Create a contingency table in a Mosaic plot. So we have to use 2 categorical variables right here. Let's take another timestamp and talk about the Mosaic plots. So here we go. Stat Tool 1, Mosaic plot visualization. So when it comes to visualizing a Mosaic plot, as we said, there's 2 categorical variables. And with the 2 categorical variables, we can go here, and we're not doing the assignment. I'm doing something similar, so don't do what I'm doing. Don't do what I'm doing. Don't do what I'm doing. You'll lose points. We want to look here at 2 categorical variables, so I'm going to remove the numeric, and let's look at today somebody's family economic level and if they're in the honors program. Once again, these are not the variables you're doing. These are not the variables you're doing. Can someone type in the chat for 100 points? These are not the variables on our assignment. You are not doing these variables. You are doing different variables. You're doing family order as the Y variable. The Y variable is up there in the Y value, in the Y field. And the X variable is the explanatory variable, which is the X. Here's the X field. Here's the Y field. Make sure you put yours in the respective fields. These are not the variables. 100 points if someone types in the chat. These are not your variables. These are not yours. I'm not doing that. Not the variables we're doing. Great job, Maria, there. 100 points. These are not your variables. But you will get a Mosaic plot and a contingency table. Now, if you look right here, and this does luckily go in order, pretty interesting stuff because I do see some sort of an association right here. This does worry me a little. I don't like that it's that because we do see right here, but this is if somebody is in the honors program based on their self-described family income level. And we see that of these students, and let's make our contingency table look right. We're going to go right here and we're going to click this button, remove the total percentage. What does it say we should have? Let me check the instructions. Remove total and column percentage. Remove total and column percentage. Remove total and column. So you go to this red arrow right here, remove total and remove column. And now we have the row percentage, and we also have the count, which is the amount of observations. How many students were lower class? And Maria, this will kind of go into your questions right here about how we'd look at the status. We'll do the question next around the Canvas content, but this is kind of the same idea behind it with looking at the contingency table. How many students were lower class in this data frame? Or in this table, I should say. Data frames we call them 320. So how many students were lower class? Just looking at this, you can be like, oh, there were this many students who were lower class, and that is how many? Who knows in the chat? So there were how many students who were lower class? Just looking at this. All of this, there are how many students who were lower class? Maria, my next question in my head. 15, Maria, great work right there. There are 15 students who identify as lower class, and of those 15, 100% of them are not in the honors program. So this is the within right here. This is the within, the conditional. Of the lower middle class, 89% of them are not in the middle, not in the honors program. There's the no. And you can see it right here. Here's the 89%. And then you go down to the next one. The 93% is that respectively. The 84% is this respectively. And the 82% is this respectively. You notice here these groups have the highest amount of people in the honors program. Similarity between these. And I do want to see, oh, it is just barely. For those who know what that is. We're not talking about that yet. That's end of the semester. One way to make your visualization look super nice is to grab this right here, click it one time, and then drag and drop to right there. Wait till you see the long bar appear, and you get a side-by-side visualization. So we would describe that the higher class has the most people. Not that it has the most people. Uh, that somebody in upper class has a higher what of being the honors program. Somebody, and so this is how you would describe this for your write-up. Somebody in upper class generally has a what probability. Like when you look at the two highest classes right here, which we would describe, somebody in the upper classes would have a what or what being the higher probability. Exactly. And that's what we're looking at is the people who are most in the honors program are actually the middle upper, but that's probably due to a lot of people being there. But also, interestingly enough, this one has a good bit many. But that might be a lot more uncertainty in that group because there's smaller sample size. But either which way, we do see the two highest probabilities come from the middle upper and the upper class, where the lower classes right here generally have lower probabilities, but the 15 and 17% right here are the highest of the 5 probabilities, with the lowest being here and lowest being here. So it almost goes in direct order. Like this is if you switch the order of these two, it would go in perfect order of an increasing probability with social economic or family economic level. So besides that small change of increase, decrease, increase, you switch these two. And this is a self-described thing. So we didn't ask people like, how much money does your family make? Because you'd be shocked. Some people would say like, I'm middle class. My family makes $400,000 a year. And you're like, $400,000 is middle class? And they're like, yeah. And they're like, oh, okay. That's just, I mean, to me, it's not. 400,000. What would 400,000 be? How would you describe that? Would that be middle upper to you? Would that be middle class to you? Would that be upper class? And they have to say, well, 400,000 where? New York City or Knoxville, Tennessee? That depends a little bit. I'd say in Knoxville, nah. In Knoxville, I'd say if you're making $400,000 a year, you're upper class. If it's New York City, I'll be a little generous and maybe say middle upper. I'll be a little like generous towards like, okay, maybe then it's middle upper. Yeah, and it's a lot of context because it's spending power is different where you're at. Like, what is your money actually worth in New York City? What is your money actually worth in Knoxville? I really saw this when I went to California and I went into like a Walgreens. I was like, I'll just pick up some soda and chips. And then I was like, what? Why is soda and chips like $6? I'm like, it should be like $2. But they sell soda for like $2 and a bag of chips for like $2.50. And I'm just like, this is ridiculous. So spending power is going to be different. Like what money is worth is what money can buy. So yeah, so I'd call it upper too. Like if I just say like generally speaking, I'd say $400,000 is upper, but all that stuff for 320. I looked at assignment 3 and I'm confused. Should be. We'll take a look. Which one do you want to look at? Sure, right there. Tell me which one, and we'll put it. So assignment 3. Tell me which one, and we will take a look at that next, and I'll double check everything should be right there, and we'll take a look. So with this right here. Yeah, this is basically our write-up. So this is the Mosaic plot. You want to screenshot this. Take a nice, neat screenshot of your screen using snipping tool. You could grab that Mosaic plot thing right there. And look at that, nice and neat. We'll go over to Microsoft Word right here. Just the first one. Okay, we'll do the first one here coming up in just a little bit. And check out how to do that. It's going to open my 10,000 Word documents. It's opening them all. Like literally all my Word documents. Okay, so let's go here. Let's drop it in and then include a short write-up. So I don't usually do the assignments. I got the oh, okay, cool. Let me make sure it's right. Got me worried now. So we'll be checking that here in just a little bit. Great question. Side-by-side box plots, which was the one you asked for. So let's go check this out next. Let's do a quick timestamp here and talk about some side-by-side box plots. So 1440 Stat Tool 1 side-by-side box plots. Okay. So when it comes to side-by-side box plots, we have to remember that a box plot is a univariate quantitative display of data. So box plots multiple would create side-by-side box plots. So a singular box plot is just going to be a box plot, quantitative up there in the top thing where it's quantitative. But box plots, if you're using multiple box plots, they could go side by side. You could stack them. Like you could make stacked box plots if you wanted, just put them on top of each other, or you put them side by side. So technically you can make side by side histograms. There's lots of ways to do these. Side by side just means multiple box plots. So when we talk about box plots plural, we're talking about a kind of bivariate display where we're making multiple groups with a quantitative variable being analyzed on the y-axis. So when we think about this right here, we have a quantitative variable, high school GPA, and then we have a categorical variable, are you born in Tennessee? So we're going to use Graph Builder to make this right here. You have the option to make them horizontal or vertical, so they're kind of stacked or side by side at that point. You need the icon above the graph to create the box plots. Make sure the 5-number summary is selected and click Done. Make sure to click Done after taking the screenshot. Include a write-up of the key differences you see. So let's go over here and check this out and run some analysis. So if we are on Graph Builder, we need to take, like it says, a quantitative variable. Now make sure to do yours. Make sure to do the ones you're doing. Like you'll do high school GPA. You'll do high school GPA. I'm not going to do high school GPA. Let's look at, thinking of something where there might be differences. Ooh, expected starting salary based on if somebody's in the honors program. Now let's make it a box plot. So box plot button is right here. Let me repeat the process in case I did that too quickly. You take the variable, like your quantitative variable, it's blue, and drop it right here in the Y field. So that's how you put the quantitative Y in. And then when you go right here to honors program, which is going to be my categorical X, not yours, you're going to drop this into the X field right there on the X field. Yeah. Oh, Sharia, that's so good. And we should check that out. We should check that out. It's always great that we put some 320 in these videos to help out. So now I'm going to go down here. You just have to scroll down a little bit and go to the 5. Where's my 5 number summary? Where you at? 5 number summary. Wait, what? Oh, gotta click the box plot button first. There we go. Now, where's my 5 number summary button? There we go. Oh, you can do a little. You could, if you do something different. If you. Ooh. No, don't do that. Don't do that. That's fine. I like that better. Oh, don't do that. I've seen those. I don't like those box plots. Yeah, I don't like that right there. It's kind of showing where the upper whisker is at right there. Oh my gosh. Wow. Yeah, I don't like that. I don't usually analyze box plots that look like that. A lot of information. If you hover over it now, we'll give you the information relative to it. So it's giving the quantiles right there, the min, the Q1, the median, the Q3, and the max. It's important we know. So let's take a moment. Let's hit done. And then let's make our screenshot not look crazy. Well, it adjusts to the screen size. So we're going to make it look nice and neat right here. Looks good right there. I know, it's too much for me. It's too much. And let's take a nice screenshot. There we go right here. Looking good. I'm not going to include that on the side because it's redundant information and it just extends the screenshot with a bunch of blank space. So, you see, I got that little bit extra. We can fix that post. Let's fix that in the post. So there we go right here. We say we want this to be a little bit smaller. And then we're going to go right here because I don't love that little bit of blue. I'm crazy about my pictures. So we're going to go right here and just grab this and do this. That's the crop button. After you click the picture, you can always crop and remove a little bit. Will our numbers be that big? If you want your numbers to be bigger, great question right there. If your numbers are not big, so check this out, hit Control Shift or Command Shift, I believe on a Mac, and then plus. So if you want your numbers to be bigger or smaller, Control Shift plus or Control Shift minus. That's like the zoom on the numbers. So Control Shift or Command Shift plus or minus to increase or decrease font size. I believe that's also under the view. So one of those under the view does it. I think it's view, but Control Shift plus or Control Shift minus to decrease font size on graphics pretty quickly. So Control Shift or Command Shift plus or minus. Hold Control Shift and then hit plus or minus. I've got both the buttons pressed and just hitting plus or minus. And then just choose an appropriate size for however you like to view your graphics. But you can also edit titles if you want. Like if you want to say expected, whoops, got capital on. Expected salary by honors program. If you wanted to do something like that, you could, like the actual digits, like our data set have the big numbers. Oh, yours probably won't because you're doing GPA. Yours probably won't because you're doing GPA. So you're going to see more like 3.7, 4. You're going to see smaller numbers than what I see right here. And it's important to know where these numbers are coming from. So whenever you look at a box plot, you have to be very careful. And here's the number one thing to be careful of. So this is basically teaching to the test. We love our teaching to the test moments. So when you are looking at box plots, the range of the data is the min to the max. So the minimum value to the maximum is the range of the box plot, which is this value right here. The IQR of a box plot is Q1 to Q3, and it is the box of the box plot. Be very careful because when doing min and max, you must consider that these could be the min or the max. Technically speaking, when doing the min or the max, you must always remember these things could be the min and the max. Sometimes they are, sometimes they're not, like right there. So what things can be the min and the max? Like right here, you see them. And what things might be the min or the max. The min or the max could be these. So what things can be the min or the max? And sometimes people forget this when doing the range. They forget to include these values. The min or the max could be what? Outliers, Maria, 100% right there. Do not forget those things, that the min or the max could be outliers. So another thing to know too is the median is the line in the middle of the box plot. Sometimes it's not viewable because it overlaps the quantiles. We're just color coding so we can see what's going on. There's some key differences to note between these box plots. First off, people in the honors program have a higher median, so they think they'll make about 70,000 compared to the 60,000 that the non-honors program would make. They also have a greater spread denoted by the IQR. So here is some things I think you should do. Compare medians, mention the values. Compare IQRs. Compare outliers. I'd write some sentences comparing these things because they're all things we can see in a box plot. Like, there are extreme values in both groups where both groups have people who think they'll make 200,000 when they graduate. I mean, great job for them. I don't make 200,000. Be amazing right there. That's craziness. Just Owen Wilson, what do you think about that?
Wow.
He's impressed. So really some interesting results right here. It's like, don't just say like the median for this group is higher, the median for that group is higher. Mention numbers. So mention numbers. It's not a hashtag, it's a number. Mention numbers, mention hashtags. So with this right here, I do want to point to one last thing. This is something my students, don't worry, often forget what it's telling us. What is the value right here telling us? What is this? It is the minimum, but why is it a whisker right there? Who knows what that is? Like, that's a question mark if you can't tell. Who knows what that value highlighted in blue is right there? Like, what does it describe to us? Like, beyond it being the minimum, why does the whisker extend to there? Like, the whisker also extends up to here, which tells us something. What is that telling us? And oftentimes there's a confusion between some ideas of what box plots have. Oftentimes I hear it called something that it's not, and I just want to kind of make sure we put that in this video. So if someone thinks, oh, that's the this, we can say, wait, no, it's not. Don't worry. Maria, I'm throwing 200 points. That is correct, and sometimes it is the minimum. Maria, you have been studying up and practicing. Sometimes people call it, don't say what it is. Oh, but it's not technically 1.5 IQRs. It can extend down that far. So a lot of times people think it's the fence, but the fences we don't actually see. The fence would go down to about 1.5 IQRs and 1.5 IQRs above. So these are where the fences are at, and we don't see the fences. Like, the fences are purely a graphical technique. That point right there, as you said, is the lowest number that is not an outlier, which is sometimes the minimum because there are no outliers. Does that make sense? What you said right there, Maria, that is the lowest number that is not an outlier. Since there are no outliers, that is the minimum. That point up there, the higher blue one, is the highest point that is not an outlier, but it's not the maximum because there are outliers. Does that make sense? And the whisker can extend to the fence. You notice that that whisker on the bottom is shorter. It doesn't go down 1.5 IQRs. It's very close to where Q1 is because there's just no data below that. So it goes down to the lowest point that is not an outlier, and it could extend down this far technically, but there's no data there. Does that make more sense, Maria? Oftentimes, and that's why I mentioned this. And Maria, I want to give another 100 points. Thank you for engaging that conversation. Usually there's confusion about what the whiskers show. The whiskers go to the highest or lowest point that is not an outlier and can go to the min or the max if there are no outliers. They can extend as far as the fences, which are 1.5 IQRs above Q3. So 1.5 IQRs above Q3 is where this fence is. And then below this Q1 is the fence, the lower fence. Extend to the lowest number, highest number that is not an outlier. Exactly. And they can go as far as 1.5 IQRs above Q3 and 1.5 IQRs below Q1. And if anything's outside of that, they would be an outlier. Sometimes they don't extend that far because there's no data there. If there's no data, then they just don't go there. So a deeper understanding, this has almost been a mini lecture on box plots. Hey, Troy, what's up, Troy? Troy, 100 points senior right here. So we just did a kind of a mini lecture on box plots. Check it out. Kind of a great review of what you're learning and what to talk about when we compare the medians, which are going to be this blue line right here, or excuse me, pink. Medians, compare your medians, compare your IQRs, Compare if there are outliers, which I guess are kind of your, it's all these things right here. Talk about some outliers, compare those, and you've kind of got some ideas, and make sure to mention the values. Like, oh, there's some people who think they're going to make $200,000. They are definitely outliers. There's more outliers in the not honors program because they have a lower median probably, and lower IQR or smaller IQR, less variation in that data. So compare the IQRs and mention the values. Find the value of the IQR, 20,000 versus 35,000. So anyways, we'll do that. Just subtract those values. Anyways, that's got it. Let's get back to the main screen. So that is all of visualization 3 right there. Oh my gosh, visualization 3. We got Canvas content born in TN coming up now. Let's talk about how to find out probability of someone being born in TN. I was not born in Tennessee. You can probably tell sometimes when I talk. Like he's from the north. He's like, make a box plot. You know, like he's not from here. You're not from around here, are you? Make a blocks plot with dot plot on it. Histogram. Let's go and Canvas content. I like when my accent cracks people up. And the problem is I've been stressing some words more often as for comedic performance. And then I notice sometimes when I'm not teaching. Sometimes I'm not teaching and then I say something and I'm like, oh no. I'll say like that's bad. And I'll be like, oh no, my having fun with my accent. Having fun with my accent has caused me to speak more with an accent. Since I'm on stream speaking with an accent a little stronger than I usually have, I have created it. Coffee still? Oh yeah. I should stop. I know it's fun. I don't know. I growing up, I always wanted to do accents and stuff and do voice work. Yeah, we just did some visualization 3. I always wanted to do voice work right there, Shreya right there, and everyone. So I don't know. It's fun. It's fun to be a character. I'm a little more animated online than I normally am. I'm pretty animated in person, but you know, online you gotta have a little more fun. We were watching someone stream on TikTok last night. We were like, a lot of things I do too. Let's go check out this question. Here we go. Okay, so what is the probability of a student being born in Tennessee? Now, here's the number one way to handle these questions when you get to the test. When you get to the test, ask yourself 2 questions. First off, is this conditional or marginal? And then find the probability. Okay, so find the probability. So here's the 2 things I talked to. That's too funny. Oh, like you're talking about me, right? See, yeah, it's a problem. I'm doing it. Gotta be careful. It'll eventually stick, and then it'll be my accent. So when we say, what is the probability of a student being born in Tennessee? Conditional means you set a condition. Like, that would be conditional on students not being born in Tennessee. This would be conditional on students born in Tennessee. This is conditional on a students not being in honors. This would be conditional on a students being in honor. And this is marginal, and this is marginal. Now, where are the marginal distributions? They are in the where. The marginal distributions, if you say a marginal distribution, it's in the where. That is a conditional. There's multiple conditionals. There's technically 4 ways to do conditional here. The marginal distributions would be where. Just kind of an easy thing. We always remember this. The marginal distribution, there's 2 of them, and they're both in the wheres. I'll show you the other marginal distribution right here. It'll make green when I overlap it. They're in the margins. Exactly. So marginal looks at one variable only and just talks about something like that. So when we look at this, are we doing a marginal distribution or a conditional? There's technically 4 possible conditionals, and there's 2 marginals that we could consider for this question. So is this question, what's the probability of a student being born in Tennessee, marginal or conditional? Which of those would it be? Marginal or conditional? So would this be a marginal, like in the margins we're answering it, or would it be conditional, like we set a condition for one variable? So that's what conditional means, is you say like, given this is true, or for these students, what's the probability of the other variable? So is this marginal or conditional? Which of these? So we're asking, what is the probability of a student being born in Tennessee? How many variables are we considering right there? 1 or 2 variables? So just break it down to that. Marginal is going to be 1 variable being considered. Conditional would mention both variables. So it says, what is the probability of a student being born in Tennessee? Is that mentioning just 1 of the variables or 2 of the variables? So, and Maria, thank you so much. Great practice right here, Maria. Is that, So one variable, exactly 100 points right there. So it's mentioning one variable. So if we're mentioning one variable, that would be a marginal distribution, because marginal distributions only consider the variable in the margin. Conditional has to mention both variables, like what is the probability of a student who is not honors being born in Tennessee? That would be these numbers right here. So that would be, what is the probability of a student who is not honors being born in Tennessee? But over here, when you look at this right here, it says, what is the probability of a student being born in Tennessee? That is, how many students are we considering right here, Maria? Like, if you had to describe this to me, how many students are the 923 of the ones we've talked to? So what percent of that is that? 923 would be how many students? So 923 is how many of our students from this survey? And what's interesting, let me do this. It might be easier to look at it if I do the following. I'm going to insert something right here. Shape. Boop. That might help. Exactly. You're seeing, Maria. And what I've done right here, when you consider a marginal distribution, honors doesn't even matter because we're only looking at the one variable. So I'm blacking out that variable so you don't see it, or we can white it out right there. So you don't even see it anymore. I'm just making it so that information is not even available. Make it look nice and pretty right here. I'm going to have a southern accent. But now we have this right here. That is the marginal distribution, and marginal distributions just analyze one variable. So we're not even looking at if they're in the honors program. It's just because now we have the information to say, what is the probability of a student being born in Tennessee? And we're just looking at the margin. So don't even consider the rest of the data. I think this might help view it. Margins are just one variable. Like you don't even have to think about, are they an honors student? So because all we're just asking is, what's the probability they're born in Tennessee? And Maria, I think you've got it. Another 100 points. Does this help make more sense of it? So the other information is not that we're trying to confuse you, but when you just remove that other information, it's clear to see that we're only looking at the margin right here, I should say, the margin where it has just the information on if a student is born in Tennessee. And you just did perfectly right there. The answer is 547 divided by, and great work, good practice, 547 divided by 923. And whoop, I did 547. There we go. There we go. And then round that to be 0.622. And so that would be the answer right there. Don't multiply by the 100. Notice how it says the decimal format right here. I do try to adjust questions. If you feel you got something wrong that you shouldn't have gotten wrong, let me know. I think pretty much everybody except 2 people got their points back because I was like, actually, the answer was this. Sorry if that was you. But no, I appreciate all the emails. You're welcome, Maria. Keep asking those questions. I want to throw you another 100 points. Maria, you're doing exactly what you should do. Jump in here, ask those questions, and we can give some deeper understanding. So I think sometimes graphing it out this way and showing what we should consider and what it means to be marginal, where we're just looking at one variable, as we can see right here, helps a deeper understanding of the concepts. And that's what we want to do to prepare for the test. Let's jump back to the next topic. Awesome stuff. We're going to do some horse racing next. Horse racing question. We only have one more question after this. We're going to start assignment 3 for BAS 320. So if you have a question, we're running low on questions. We are running low on questions. So drop those questions in the chat so we don't run out. No, we don't want to run out of questions. We're about to do the OGIV. OGIV's an interesting graphic that shows the percentages. And we're loading up. Chapter 4 quiz. What's the time? Oh, I didn't make it in the 54. Try and find the question right now as we speak. No. Found it. Could you do the question that asks important to see whether... Yeah. We'll do that next right here. We'll do it. Let me do... We'll do it real quick right here. We'll make up some questions from that. So let's check it out. We'll do this one, 63 minutes. Let's jump into the horse racing question. Here we go. We shouldn't jump into this question. We should gallop into this question. So here we are with the horse racing question. Sometimes I don't know what I say. And what we have right here is what's called an ogive. Interesting graphic that's going to show you the percentages as you move through the data. I would suggest either zooming in on this, however you want to view it. We're going to zoom in on it to kind of help. And if you feel like you got the answer right, but you were off by a few decimals, always email me. Always be like, hey, Brian, I think I got this right. I was just off by a few decimals. Really a great way to do this question is to screenshot it and to go in and zoom in on it to get a better idea of what's going on. Now, what we're doing right here is we're actually viewing the percentages through the data. The minimum value, which is down here at the 0th percentile, is a horse that had a winning speed of how many miles per hour. So try to read this right now. Just jump into the chat and be like, oh, the lowest winning speed for a horse. So we're looking at how fast was that horse going when it ran the race. And we're like, oh, that horse was going 35 miles per hour. That horse was going 34. We're just collecting data on these horses. And as we collect the data on these horses, the lowest speed we would see, great job, Maria, right there, would be 31. So there's a bunch of different horse speeds that we have right here. Ooh, we don't have one that high. Because the highest speed, I got to be careful. The highest speed collected was about, and you have to trace down. What's the sound we make? The highest speed collected was 37.7. Great job, Maria and Mary Catherine, right there. Excellent work. Some more points in the chat. And so the highest speed collected was 37.7. Does that make sense how I found 37.7? And that's the 100th percentile, which is the maximum value. Is that making perfect sense? That I looked at where that was at. The 100th percentile is the maximum value, which I have highlighted up here. And then I trace down. We'll highlight just those points. And I trace down from the 100th percentile to where 37.7 is at. Now, you do have to kind of estimate it a little bit. Remember, in the middle of this would be 37.5. And so just a little bit above that, spam risk. Oh, I love spam risk calls. 37.7 looks to be where that's at. If you're off by like a tenth of a point, just email me. If you're off by like if you're off by like 0.3 or so, you're like, we usually make better guesstimates than that. But 37.7 should be where that's at because it's a little bit above 37.5. And so we're going to have to find some percentages in here as we move through the data. Estimate the median. So immediately when we hear the median, we should think the what percentile. Median is the what percentile. Help me out right here. Who knows what the median is? We can do some 50 points for this. But what's the median? The median is the what percentile. What is the median? The 50th. Yep. So now it's asking us to trace over here. Boop, boop, boop. You notice that's right below 36. Right below 36. So that's probably 35.9. And let's say is the median. And so we're just taking some notes right here. We can take notes on other ones. That's the median is 35.9. And now it also says the quarters, the quartiles. The quartiles represent how many quarters you've gone through in the data. When you think about Q1 right here, it means you've gone through one quarter, as like Q3 means you've gone through 3 quarters. These represent the 25th percentile and the 75th percentile of the data respectively, because 1 quarter is 25% of the data, and 3 quarters is 75% of the data. I guess it also goes through the first quartile if we do that. But that's what we mean when we say the quartiles. Like the first quartile and the third quartile represent we've gone through 25% of the data, and respectively, need to change our color on the median right there. I like to color code stuff. I feel like that's really helped when I started color coding what we're doing, because I have the ability, so why not use it? I'm not a good artist, but I like to think my logic on what I do helps. So now the 75th percentile is up here. There's 75th percentile. Oh, it's going to be a funner one to estimate. Not that crazy. So that's going to be about 36.8. So it's a 36.8. And that's where Q3 is at. Oh, Mubot advertising right there. Join Stat Nation. Mubot, you the man. Or whatever you are, Mubot, I don't know. And that's going to be right below. You notice it's not quite on it. What I'm talking about, if you look at it really closely, you can tell it's not quite on that. It's not quite at 34.5 because that'd be between these numbers. So it's 34.4. So that's at 34.4 right there. So it's not quite on it. Not quite on it. It's close, but not there, not there. So 34.4. And so now we go here to Q1. And there we go right here. Mubot's fine with that. He's fine with it. I don't know. Mubot, you cool with that, man? Mubot, where you at?
Brian, you are weird. It's okay though. I understand you, Brian. I know you're just being you.
Mubot, thank you. I appreciate that. I just don't know what to say sometimes. You are you too, Mubot. I appreciate you. I appreciate you. Thank you, Mubot. Mubot's a robot. He does Mubot things. And there's the distance. We found the distance those numbers are away. That is the IQR right there, the distance between these two numbers. Let's highlight in a different color right here so we can see it a little bit better. But the distance these two numbers away represents the IQR, which is the range of the middle 50%, the distance between these numbers. So we can find these distances right here, which is also mathematically this distance right here. But we're just kind of connecting our understanding of what's being shown to the graphic with some color coding and helping us understand what these values are as we talk about the min, the Q1, the median, the Q3, and the max, which can be shown as the percentiles right here, such as like the min, the Q1, the median, the Q3, and the max all the way up here. Max is the highest point. It's not over there. There we go. That's the percentages. We could find other values. So let's use this info. Find the min and the max if we need to. The median was, maybe I'll zoom out right here. Can I read that still? Maybe. The median is 36.8. Basically just transcribing what we've done. The lower quartile is 30. What am I doing right there? What am I doing? 35.9. The lower quartile is 34.4. Gotta make sure I don't make an error. I haven't made an error on this one lately. The upper quartile is 36.8. The range of the data is, and now we got to go to the lowest to highest. So this is something we didn't calculate. Okay, so the range of the data is, well, the lowest is 31. That's this value right there. And then the highest value is 37.7. We calculated that earlier. That's the max right there. It goes down to 37.7. So what's the range of this data? So it goes from 31 to 37.7. What is the range of that data from the min to the max? So 31, which is the lowest, to 37.7, which is the range right here. We're seeing it visually. Great job, Mary Catherine, right there, following along perfectly. That's what I like to see. I just zoomed in on pivot charts so you can give it 100 points. 6.7 helps me check my work too when everyone answers. Great job, Maria. Also, excellent work. The IQR is the range between the middle 50%, and that's 2.4, Q1 to Q3. 2.4, as long as I'm doing my math properly. We get here to a box plot one. Now, this is interesting. This is probably one of the tougher questions right here on the box plots. It can't theoretically be this one because there's all the data isn't clumped up here. Like you wouldn't have any sort of whiskers. We're really between this box plot right here and this box plot. So the question becomes, is the lowest point an outlier? So we need to go to Q1 and go 1.5 IQRs below it. So that's what we have to do because remember the fence goes 1.5 IQRs below Q1. So let's go to where Q1 is at. Q1 is over here at 34.4. What is 1.5 IQRs? Just right now, we need to figure out where the fence would go down to. Where would it go down? It's going to go minus 1.5 IQRs. So take your IQR right here and figure out what 1.5 of the IQRs are. And then we're going to subtract that from the lower to figure out where the lower fence is. This is how to figure out where it is, not where the whisker goes, but where outliers would begin. I think you're right. Kind kind of, well, not 20, not 32. I see why you're saying 32. Remember, we're going to times this by 1.5. Great work over there, Maria. Yep, no, you're on the right track. You're on the right track. Some more points right there. You're on the right track. So I see why you said 32, but we need to times it by 1.5 and then subtract that value. So you're going to multiply by 1.5 and then subtract from Q1. The formula is Q1 minus 1.5 IQRs. And so we're just showing it visually over here. I'm going to use a different color. We've got a lot of color coding going on. We're showing this visually right here by saying multiply these and then subtract that amount from it. And so I think Maria's found the spot. Great job, Maria, right there. Because we're going to subtract 3.6 from that value. So we're taking, maybe it'll look better if I do it this way with the color coding. This is what we're subtracting from Q1. So the mathematics for this is 34.4 minus the 3.6, because 3.6 is the 1.5 IQRs. So Maria's got the answer in the chat right there, 34.4 minus 3.6. And this tells us where outliers begin. Exactly, Maria. Great job. Teamwork right there. Yeah, Maria, you got it all. Great answers. That would not be an outlier because 31 is not outside of this. This is where outliers begin. Outliers would begin right here, but that is inside of it, so it's barely not an outlier. They're trying to be tricky. So they put a point that's pretty far away, but not far enough to be an outlier. A point actually has to be beyond this. I think I just misspoke. This is not where outliers begin. It's beyond this. Like below 30.8, which would be right about here, is where outliers would begin beyond it. So that point is not an outlier, and that's the tricky thing. So that would not be an outlier. And let's go right here. The distribution of speeds it's left skew, is it not? Skewed to the left. Why is it skewed to the left? Because the whisker's pulled out a little towards the what side? Why is this left skew? 3-letter word. The whisker right there is pulled out a little bit towards the what side? We can see where this one right here, this is not the answer, but this one would be symmetric right here because of this. And if you look at this right here, if you cut down the middle, because there's the same amount of data above and below the median, the data is pulled out a little bit more towards the what side on that box plot. That's how to see skew in box plots. So think about, we have two sides of the data. And that's where we go to our saying. The data is pulled a little bit more towards the what side, because above and below the median is 50%. So the data is pulled a little bit more towards the what side. Like there's a pull in this direction where half the data is more on this side of it, because the median's where 50% of the data is above or below that point. So there's a little more pull to the what side. Right to the high, left to the low. Great job. Yeah. Lower numbers exactly, both of you right there. Excellent work. Just great job practicing. And so that's the left skew right there. The typical horse race speed was 35.9. Watch me get one wrong. The quartiles, let me see right. Typical is the median. We're just going to copy paste numbers. Ooh, such a long question. We got this, though. We got this. Not today, my Pearson. Not today. Not today. Not today. Woo! Not today, my Pearson. That's our saying we came up with to when my Pearson tries to tell us we get stuff wrong. We just tell my Pearson not today. Not going to let it happen. So with that, we've aced the question. If you have questions, let me know. But really good review of box plots, understanding the quarters, the quartiles, the IQR, all this good information. This is a great question. Really goes to, like you have to pull some deeper understanding to get some of the questions and run the formulas. Make sure to kind of walk through solving the numbers, understanding what the IQR is, understanding how the fences are found. It's a very good theoretical question right here. Let's jump back into it. Okay, we have a few more questions right here related to the Canvas content that we're going to do some assignment 3. And we don't have questions after this. We still got 40 more minutes of office hours and we're running low on questions. No! We got this. And we still have coffee. Let's jump into Canvas content review. Let's do this. You're welcome, Mary Catherine, anytime. I appreciate all the questions. Just people come back and check out these videos and it helps them understand better the concepts. Some of the videos are getting hundreds of views and I love that. They're not monetized, so we don't make a penny from them. What we do get is students knowing the concepts better. And that's all we're going for. So with this, we're going to do a little more Canvas content and talk about it right here. So let's take a look at kind of the question or the data we have. And I'm going to use this to come up with new questions. And this is where you want to make sure you could quiz your friends. You could drop this in any sort of chat you're in and be like, hey, could you solve this? Could you figure out the answer to this? So let's write a question. The question we're going to write, we need to figure out if this is conditional or marginal whenever we talk about it. It's gonna do crazy things. Okay, here we go. What is the probability of a honors student not being born in TN? Okay, first thing we need to do is realize, is this conditional or marginal? Who's got the answer in the chat right now? Is this conditional or marginal? What is the probability of an honors student not being born in Tennessee? So conditional means we're looking at two variables, like we mentioned one variable and then we look at the distribution of another one. Marginal means we are talking about the things in the margins. To review, Maria, you're on the right track right here. And then what you want to do is you want to narrow it down. You want to say, since this is conditional, I'm going to only look at that information. What is the probability of an honor student? So can you solve it? Not being born in Tennessee. So this is given someone is an honor student. So of only the honor students, what is the probability of them not being born in Tennessee? So conditional is two variables. You have to mention both. Like you mentioned one and look at the probability of another. So what would be the probability here, Maria? So that's how we can narrow it down. For the honor students, there's many ways to phrase this. You could say, given someone is an honor student of a honor student. Got it. There's many ways to phrase this. So what would be the probability right here? So we figured out that this is conditional. Given someone is an honor student, so that, another way to phrase it. That, oh wait, and then, I switched, that is correct. Ignore that one. That's another way. That is correct, Maria, right there. 100 points. I did switch the question on that second version. That is correct. You are exactly correct. 15 out of the, let's circle with green right here. 15 out of the 65 that would apply to. So that's how we solve those right there. Many, many other ways to ask this, though, or different ways to do the question. We can do another one right here. What is the probability of someone who is born in TN being an honor student? So figure out, is this conditional or marginal? What is the probability of someone who's born in Tennessee being an honor student? So is that conditional or marginal? And don't ignore the things I'm writing. Could you do, yeah, let's do some serial question. You got it. I think people were lightly mentioning 320. It was kind of like, could we look at it? But I think we'll do serial next. 320, if you're here, just say, let's do some 320 and we'll do it. Because it was mentioned, but then people were like, oh, we're all right. And I was like, okay, well, we can come back to it. So we got, so wait, let me take stat 201. Serial question. Oh, chapter. You are correct, Maria. It is conditional. Now, with this, where do you think I'll start shading? Like, will I be shading where associated with 1, 2, 3, or 4? So it says, what is the probability of someone who's born in Tennessee being an honor student? Do you think I'll do my shading thing to look at the conditional based around number 1, number 2, number 3, and number 4? So just so you can see where 3 and 4 are at. They're respectively right here, even though it goes over some of the text. Maybe if I put it right here, it'll make more sense. Where do you think I will do some of the shading? Number 4, you're right. Great job right there, because I'm going to do the same thing I've done with the other ones. When I look at conditional, I'm only going to narrow in on the people who are born in Tennessee. So now, what will be the answer? So I know it's that conditional. What will be the answer right here? I think I just portmanteau conditional and answer. So what is the probability of someone who's born in Tennessee being an honors student? You can solve the mathematics of it. You can show the answer. What is the probability of someone who's born in Tennessee being an honors student? We figured out it's a conditional distribution. We're only looking at that information. Consider any other numbers. Close to the answer. So that right there is the number. It's 100 points. Don't worry. Close to the answer. Yeah. We might, and we'll look at some sure right here. I think we will. So, and thank you so much for just hanging out and being here. That's awesome. We'll do some start of the assignment, I think, here in a little bit. Very, very close, Maria. Maria, great job. Great recovery right there. Great job. Yeah, you're so close. I'm just Just give you a moment more to think about it. And it's tough because it's like, oh no, it's like I've done it too. I probably was doing that in my head too. So Maria found the answer of 50 out of the total 574. So there are 524 who are not honor students of the people born in Tennessee. There are 50 who are honor students of the people born in Tennessee out of the 574. So the answer would be 50 divided by 574. Great work right there. Good practice. Is this making more sense on how to do these? That way, if you encounter any sort of problem, you can be like, I got this. Just go through these steps right here. Oftentimes, if you break a problem down into steps of like identify if it's conditional or marginal and like highlight the answers right here, like we're doing, we'll do one more, but I hope the steps help solve problems. Like if you put steps to solving a problem, be like, let me do this methodology of solving it. And then it starts to become second nature after a while. You start to, it's like training wheels almost, which is a good thing. It helps you solve the problems and ensure you get it right. So what is the probability of someone being an honor student? Yeah, I think there's so many. A lot of times there's more numbers, so then we're like, wait, there's a whole bunch of numbers right here. Where do I need to focus my attention? So, what is the probability of someone being an honor student? So if we look at this one right here, see if you can solve it. Ignore what I'm doing. Ignore what I'm doing. I'm getting the answer help ready right here. See if you can solve this. What is the probability of someone being an honor student? Is that conditional or marginal? Correct. Yes. Actually, my brain broke for a second. We did so many conditionals, and I was like, okay, wait. You are correct, Maria. It is marginal. And let's go right here and just show it. So of someone being an honor student, we would go, so this one's a bit weird to do. I'm going to have to take this right here, and I'm blocking out everything else we don't want to see. And because when we do a marginal, how many variables are we considering? So I'm kind of helping us to focus our attention on only the things that matter. And just taking that information in. So we can only look at the information that we want to look at. So this right here, I think would do it. That's going to do it. And I should have done shape outline. Boop. And we are only focusing in on the margins. So there we go. That's just the marginal. And you got it. You got it right there. Excellent work. That is just the margins. The marginal only looks at one instance of a variable. It only looks at one variable at a time. So when we say what's the probability of someone being an honor student, we only want that there were 65 out of the 923 students. The margins are in the margins of the table, and we're just going to focus our attention in on just one. I think like removing some of that extra data so our brain doesn't see it can help with understanding the marginal distribution is in the margins. And that's what we're talking about right here when we say a marginal distribution. And there's two of them. You have for one variable and for the other, which we were talking about the other one earlier. So great work right here and good practice. We want to get quick at solving these. We see a question like this. We're like, I got this. Free points on the test. That's what we like. That's what we do. Excellent work. Drop those questions in the chat. We'll get going here on the next thing. Chapter 4, serial question. You're welcome. I will see you tomorrow, Maria. Thank you for all your questions. Excellent practice. That is really, really good practice right there. And I think that's the biggest thing is you have to practice your knowledge or else you'll forget it. I've learned so many things over the years and then just not like have me go and talk about a class I took like 20 years ago and I'll be like, yeah, oh gosh, I could say that. I did take college classes 20 years ago. Let's talk about breakfast cereals. There we go. Took college classes 22 years ago. Anyways, here we are with the breakfast cereals. I have a question 3 quiz due tomorrow. Yeah, Rachel, drop it in the chat. Let me know. Put the questions in the chat, Rachel, and we can start it up. We still got 30 minutes left. So here we go. I'm going to timestamp this real quick. Probably going to even put it... Oh, we're on the 1 hour mark. Drop any questions you have in the chat. We'll get working on it. Here we go with cereal question. So with this question right here, what is the range of the cereals? When it comes to the range of the cereals, we need to find the what to the what values. If we're looking at the range of the cereals, we need to find the what to the what values. So if we're looking at the range of the cereals, you can email me the screenshot at bstevens@utk.edu, or you could Discord me the screenshot. Are you wondering about visualization? Or if you want to mention a specific question, I can do it. Like, be like, can you do the cereal problem? If you mention a specific problem, how would we find the range of this data? So it says, what is the range? So whenever you hear range, you would say, well, the range is always this distance. So you want to make sure when you hear the range, you could use note card if you want to practice it. The range is the what to the what. Like we always hear the range. We're like, oh, the range is just this value to this value. That's the range of the data. So how would we find the range of the data? And I'll show you a common mistake with this question. The range is going to be the min to the max, the lowest value to the highest value. A common mistake for the question is to go over here and say the range is 70. Now, you have to remember about bins that any value, like this is I think there's 2 cereals in this bin. That's a height of 2 on that bin. So there's 2 cereals that are in this bin. This bin collects data that starts at 60 and goes up to, but does not include 70. So these cereals have some sort of value between 60 to 70. One of them has a value of 65, and the other one is either 65 or lower. The bin down here collects data that goes from 0 up to, but not including 10, and there is a value of 1 in this bin with 13 other values technically. So the lowest value in this bin is 1. You can see it over here on the side, and the highest value in this bin is 65. Do not think it goes from 0 to 70 just because the bins collect data. That's a little bit confusing, I do think, but the bins, like here I can show you on a histogram and jump, you could easily take and collect your data. I don't want to do a design of experiment. You could go right here and ask people's ages. Is that on my Pearson? If it's on my Pearson, let me know what the question says because everyone's quiz is different. So if you can tell me what the question says, just be like, oh, it's the rain, no rain problem, or the any sort of like, tell me what the question says, and then I can do it because every time people do a quiz, it's always different questions. So then letting me know which one it is. The range of this data right here is 7 because 24 to 17 is 7. We can add this in right here. We're just kind of seeing how the range is calculated, make sure we get it every time. So if we were to add in the range of the values, is the range not on here? There's the range. We will get 7. But the bins are subjective. So the bins are just where your data is collected. So I could collect it in fewer bins, and now it looks like there's a bigger range to my data than there is, just because I'm doing this right here. Oh, no, drop it in the chat, Rachel, and we can take a look. Just say, like, it's this question right here. Just say, like, the rain, no rain, the placebo question, or the political ideology question. Whichever one you want to take a look at, we can take a look at and bring it up here and walk through. So just let me know which one. And I think we're open to questions next. So just drop it in the chat and we'll take a look. I'll just be like rain, no rain, placebo. Just tell me the start of the question and I can find it pretty easily. So remember, the bins just collect the data. Everything I'm doing right there does not change the range of the data. So when you look at the range of a data set, you also want to go to the min to the max. And 65 minus 61, 65 minus 1 right there is 64. That's the range of the data, 64%. The shape of the distribution is very bimodal. We see a very strong bimodality to it. So there's 2 peaks. That's where bimodal is seen. Once again, I do think before you answer the question, try to come up, or before you click the answers, try to come up with an answer that makes sense to you to be like, how's it look? Magazine article on the impact. Yeah, we'll do one next. You bet. Let me grab it so we don't forget. And let me put it right here. There we go. So magazine article, applicant's ethnicity. It is our next question. You got it, Rachel. Next question for us to do. You got it. And so the shape of the distribution is very bimodal. What aspects of the breast material might contribute to the shape? You're welcome anytime. Yeah, thank you. Just always say like, oh, it's this question, and I'll find it very quickly. When you look at this right here, you really have adult cereals, which are boring, like Fiber One, which has like 1 gram of sugar. And then you got like Fruit Loops, Lucky Charms, Rice Krispie Treat cereal, all the good stuff. So I would say when you look at this, they don't have similar sugar content. That's ridiculous. There's variation. Cereals either tend to be very sugary or high or low sugar. That's true. It's not the variation, but the modal areas. The bimodality right here, this part is talking about the bimodality because it's asking about the shape, the bimodality, and you really have 2 areas of concentration of data. So that's what they're referring to. There is variation in the data, but they're talking about the concentrations of the data right there. Are all children's cereals higher than adult cereals? Yes. The minimum child cereal looks to have about 38 grams of sugar, where the maximum sugar in an adult cereal is 28. So it's almost like there's a classification, like if you have this much sugar in it, you're a children's cereal, because children need sugar apparently. So that is a true statement of fact with the maximum here and the minimum here. There are no outliers. Like if there was a point up here, then that would not be true about this statement. Which group of the cereals varies more? So when you look at this, variation is considered by two metrics right here: the range of the data and also the IQR. Those are two measures of spread. So when you look at the range of this data, it goes from about 1 to 28, which is a spread of about 27. This data goes from about 37 to 65, which is about 27-ish to 28 exactly. But the IQR here is much smaller, indicating that the 50% of data, the middle 50%, is more concentrated. There's like a tighter concentration of data in that region, and that shows you how spread out that data is from the 25th to 75th. So although the ranges are similar range between here and here, the IQR is smaller for children's cereal, indicated by right here, which is a smaller spread. So although the ranges appear to be similar, the IQR is large. No. Although the ranges are similar, the IQR for the adult cereal is larger, indicating that there is more variability in the sugar content in the middle 50% of adult cereals. I think we've done everything properly. We have. Good question right here. Good practice on box plots and a histogram. So interestingly enough, this histogram here is only univariate because it collects both groups into one. And this is a bivariate side-by-side box plot. So whenever we say box plots, the plural, we're usually talking side-by-side or stacked bar plots. Box plots. Oh my gosh. Let's go back into it. Next question. I think if I'm problem with the visualization, it asks us to take the column percentage out, but takes away the ability to compare the data. Well, no. So good question right there, Troy. I can show you right here. If you have the, so you will want to remove the column percentages. So if you take a look at this right here, Troy, tell me from which of these values, and I want you to use a row percentage right here, which of these groups were most likely to be honors students, and then use a row percentage to justify what you're talking about. So the row percentage is all I have. So Troy, great question. This is kind of a quick one right here. So with the row percentage right here, which of these groups was most likely to be an honors student? So use the calculation from the row percentages to find those numbers. And then it's important to also know how these numbers are found. I'll show how to calculate that once you do it, because the row percentage is going to give you a conditional distribution. So which of these groups were most likely to be honors students? So it kind of relates to what's going on right here. These are the row percentages right here, and these are the row percentages right here. Which of these groups were most likely to be an honors student? Was it the lower, middle, upper, or upper class were most likely to be honors students? And so the row percentages will tell you within these groups which of them was most likely. And the group most likely to be an honors student was which group? It would be which one of these? Upper class, but mine looks different. The X and the Y axis are flipped on the visualization instructions, I believe. Let me double check. I'm going to double check right here. I'm going to look right here. We're doing a quick check. I'm going to do, Rachel, thank you so much. Let me do a quick check. Family order as the Y and broken to bone as the X. Well, no, I think you might, and then what's it say? Include a short write-up using the row percentages of the size of cells. What you'll be looking at is, of the people who've broken a bone, what class do they come from? You're not predicting if someone breaks a bone now. You're predicting someone's family order. Thank you, Rachel, so much. So does that make sense? You're predicting somebody's family order. I think that's maybe where the confusion is. So you'd be saying, like, of the people who've broken a bone, what is their family order? That, like, so you're looking at, it's not much of a difference, right? When you look at of the people who've broken a bone versus of the people who've not broken a bone, and you look at the probabilities of them being in different, because I'm not showing it right now, I don't want to show it. But you'll be looking at the people who have not broken a bone and the people who have broken a bone. And given someone's broken a bone, what's the probability they're from this class, or family order? It's family order, right? Not class. That they're the youngest, middle, oldest, in the middle, all those different things. And so you're looking right here to see if, broken a bone would explain why somebody is a certain family order, right? It's family order, right? And so you'll look within whether or not people broke a bone, whether that explains their family class. Yeah. So then it's, no, you're fine. 100 points both of you right there. Don't worry about it. It's a good, quick thing. But Troy, great job working on this early. Just, you notice, like, little question right there and just, like, boom, right on track. So great job right there. Great questions. Let's jump into it. Let's see right here. We're going to do the applicant question. Thank you so much to everybody right here. Sometimes we do a little quick question right there. And I appreciate that so much. Everyone is so positive. Rachel, 200 points for positivity. We love it when people are just like, oh, no worries. Don't worry. You got this. This is a little quick question. I figured that wouldn't be a long segment, so I just kind of did it, appended it onto one part right there. We're going to do the applicant and whether or not they got accepted on the quiz. Let's go take a look at that. Quiz 3 right here. Applicant acceptance. Always just throw in a question if you got it. Cool. This is good stuff. Rachel, awesome work. Let's jump into it. And let me take the timestamp. Applicant acceptance. Here we go. Put on this chapter 3 quiz. Okay. And we are at 35 minutes. Cool. Let's do this. So with the applicant being accepted right here, we need to start thinking about, is this conditional or marginal? We were doing some really great questions earlier where every time we did a question, we asked, is this conditional or is this marginal? So we're going to kind of ask the same questions here as we go through this data. So remember, our first question will be, and you can just say C or M in the chat, is this conditional or is it marginal? So when we look at the first question right here, conditional means it looks at both variables, and marginal means it just narrows it down on one. It first asks, what % of all applicants are Asian? Is that talking about two variables like their admission decision and their ethnicity, or is it talking about one? So what do you think? What % of all applicants were Asian? Does that mention both variables, or does it just mention one of the variables like ethnicity, admission decision? With that first question, does that mention two variables or one? And this is a good way to figure out, is it conditional or marginal? So does that mention two variables or one? Because it just says what % of all the applicants were Asian. It just mentions one. Great job right there, Rachel. It just mentions one. So that means it's actually a marginal. No, it mentions only one. Don't worry, it just mentions one. Because it's just saying of all the applicants, which would be all these people here, what % were Asian? So that is a marginal distribution. Does that make sense? Marginals are in the margin. Good way to remember right there. We have a marginal distribution down here, and we have a marginal distribution over here. There's two marginal distributions. We're not considering the other one right now. We're only focusing in on this data right here. So if you want to figure out what % of all applicants were Asian, what mathematics would you do to solve this? So you're only focusing in on, don't look at any of this stuff right here. Don't look at any of that right there. Just look at where I've highlighted. What % of all applicants were Asian? What mathematics would we solve? It'll help me double check my work. So what % of all the applicants, because we're not considering the other variable, we're just saying of all the applicants, everybody in this data set, what % of them were Asian? So what would be the mathematics to solve this? So take a look at just the data that's highlighted for you right there. Great job, Rachel. Excellent work. 458 divided by 1346. And now I get to double check my work right here. So excellent work. And then remember, every question we ask, we're going to ask, is it conditional or marginal? And it says to one decimal. I think it wants us to multiply. It wants as a %. And let me know if you ever get something wrong. A little worried about the percentages right there, but we'll think it's all right. What % of the students accepted were Asian? There's the second one. So is that marginal or conditional? What % of the students accepted were Asian? What % of the students accepted were Asian? Is that going to be a two variable or one variable conversation? What % of the accepted students were Asian? So is that a two variable conversation where I'm talking about two variables, or one variable where I'm only mentioning one of them? Is that a two variable conversation or a one variable? Is that a two? And don't ignore these numbers for a moment. Is that a two variable conversation or a one variable conversation? Say what % of the accepted students were Asian? It's a two variable conversation. That means it's conditional. So where do you think I should start shading? Do you think I should start shading here? Or do you think I should start shading here? Or do you think I should start shading? What number do you think is, hopefully I didn't confuse you. No, you're fine, Rachel. You're doing excellent. 100 points, Rachel. You're doing great. You're faster than a lot of responses I get. You're doing excellent. So no, thank you, Rachel. You're doing excellent. Where do you think I should start shading? Around what number right now? Like it says, what % of the accepted students were Asian? So should I shade horizontally on 4, 5, or 6, or vertically on 1, 2, or 3? So where should I start looking conditionally? Oh, you might, Rachel, you've already got the answer. Rachel, great job. We would go right here. I was doing it in step out. You got this. There we go. What % of the accepted students were, of the 191, what percent were Asian. That is the answer right there. Rachel, excellent work. Keep it up. You got this. We're just practicing, and you are doing a great job. And so we'll go right here. I ask a lot of questions. If you have the answer, you're always free to give it. So what percent of Asians were accepted? M or C? So this is what we're practicing now. Marginal or conditional? What percent of Asians were accepted? So I'm kind of like giving some hints by stopping on something. What percent of Asians were accepted? Is that marginal or conditional? Marginal or conditional? What percent of Asians were accepted? Is that marginal or conditional? Marginal means we're only talking about one variable. Conditional means we're doing both and looking within like the two variables. So is that marginal or conditional? What percent of Asians were accepted? Would that be marginal or conditional? If you want to send me an email, I could look at it and double check the work. Watch me get them all wrong also. It's very easy to like reverse and look at the reverse the orders. If you want to send me an email, I can take a look at it. But let me know, because I can see maybe it was decimal differences, because decimal differences will do it. If you're off by like a decimal, that can do it. If you're 0.1 off, I don't care. I'll just give you the points. I mean, rounding's important, but you can get like a bad grade because you basically got the answer. So what percent of Asians were accepted? That is going to be conditional right here. So we need to go to just the Asians right there. Yeah. Oh, definitely. So how would we find this? What percent of the Asians were accepted? What percent of Asians were accepted? Go to the whites. Any group here, we can say what percent of this group was accepted. How would we figure out this answer right here? What percent of Asians were accepted? What would be the mathematics here? To only focus in on those numbers. What do we get? Cool. Yep, that is correct. There we go. 56 divided by 458 times by 100. Maybe you entered these in as decimals. If you notice right here, it wants as percentages. So you have to times by 100. So if you entered in as a decimal, let me know. I can fix it. The percent of all students who were accepted. So is that marginal? Just put an M or the C in the chat. Percent of all students who were accepted. Put an M or C in the chat for marginal or conditional. Percent of all students who were accepted. So the percent of all students who were accepted, is that marginal or conditional? The percent of all students who were accepted. So the percent of all students who were accepted. Yes, marginal. I was trying to say it really quickly to not pause on any portions. So we need to go to all students and look at accepted. And that's in the margins, hence why we call it marginal. No, it's not too, because it's just like of everybody. Everybody is not like subdividing them down. So when you're saying like of everybody, that's not really a variable. It's just like what percent of students were accepted. So now we're not doing like mentioning. Notice how we're not mentioning an ethnicity. So we don't mention ethnicity right here. We're just looking at the one variable of like what percent of people were accepted, and marginal just looks at one variable. Does that make sense? Like you don't need that information right there. No, good questions right here. So when you look at a marginal, you don't even like talk about like the other variable. You're just like, okay, what percent of students were accepted? And we would go right here and we would say this, and that's got it. I might take a look at and then so what percent were accepted? 13, 4, 6. So that's the percent that were accepted. I'll probably get one wrong. I'm due to get one wrong. Gambler's fallacy. Not a real thing. Hey, Griffin. Great to see you here, Griffin. Previous semesters, right? Griffin, not today, my Pearson, right? And good to see you here, Griffin. Trying to think. Hey, Brian, I have a question about chapter 4 homework, part 3. I can't see your summon. Yeah, Kevin. Which one is it? What's it start out with? Cross your fingers. You ready? Woo! No, we have not gotten one wrong in a while. We are due to get one wrong. Don't want to cough. So, Kevin, which one is it? Let's do that one. We'll end office hours with that. Kevin, which one is it? Let me know. Yeah, Griffin, good to see you here. I miss seeing my students in person, but Griffin, I remember your name. I'm like, previous semester. Griffin, 100 points. Sorry, we probably reset MUBOT points. Back-to-back sim leap pop compares the percent changes in population for two regions. Let's do it. Good stuff with back-to-back stem and leaves. It's funny, I remember names now. I'm like, okay, that's the name from this previous. I'm pretty sure last semester. Pretty sure last. Okay, cool, awesome. You email me and I'll take a look. Thank you so much, Rachel. Stat 201, Chapter 4 quiz. Region back-to-back. Region stem and leaf. Ooh, good stuff right here. Let's get the question going. Regional stem and leaves. And need to find it. Watch me find it first. No, didn't find it. Back-to-back stem and leaves are pretty interesting. Yeah, Troy, 100 points. We're all about that positivity here. Love it. I felt a little mean yesterday. We were talking about beating up the chapter. I don't know. It was funny, but we're about positivity. We're only mean to chapters and take information from them. Let's do the back-to-back stem and leaf comparing populations in regions. Here we go. Let's do it. Let's check this out. Back-to-back stem and leaves. Compare what kind of data? They compare a quantitative variable like what is the population growth, which is a quantitative metric. Yeah, Griffin, so good. Enjoy work. Enjoy your time. Thank you so much, Griffin. Swing by anytime. You're more than welcome here. And so region 1 and region 2 is categorical. So do remember we have a graphic showing us what we're doing right here with back-to-back stem and leaves. Is it on here? Ooh, it'd be right here. But scribble on that screen, back-to-back stem and leaves. Back-to-back stem and leaves are a quantitative categorical display data. I should have put it right there. I'm sorry. Maybe I might need to edit this picture and put a little extra on there. So it's always more graphics. Like you could do stacked box plots technically. So there's lots of things you can do that we don't have on here. So this is just almost the beginning, but the main key components. So back-to-back stem and leaves should be a categorical X and a quantitative Y. And if you look right here at the axes, you do see this is breaking apart into categories, and this is quantitative. Now, one of the first things to notice is that region 1 has a much tighter distribution. It goes from a value of 1%, because this is 0.1 for region 1, to 1.2. This is an observation right here, as are other numbers. All the observations are kind of clumped towards this central modal area, where there's 2 modal areas in region 2 with an extreme outlier here of 63 and another slight outlier of 41. Actually, in truth, it looks like 63 is the only outlier. I am 99. If you look at how far away that point is, just with one of these graphics that might be accurate, 63 has to be an outlier because it's way more than 1.5 IQRs above Q3. Remember that outliers begin 1.5 IQRs above Q3. Now, basically, you can narrow it down to, or is that an outlier? Let's double check. Is it? That's got to be. Visually speaking, it has to be. This is way too far for the whisker to extend. So actually we're narrowing down between these two. These two are the answers it could be. And we might be able to figure it out between these two because one, there is data. I'll tell you why this one's wrong right here. The data doesn't stop right here at 40. Does it? Let me look at the data. The third quartile is not, there's no data right here at 40 for the third quartile. There's no data right there. So this one has to be wrong because this is where the 75th percentile is. The 75th percentile might be closer to 30 or 32, but there's no data right here for where that quartile would be. So this data has to be wrong. This one's also ridiculous right here because that whisker goes way more than 1.5 IQRs above Q3. That one is visually wrong. We're doing this one a little bit different than we've solved it previously. We're kind of visually solving it for the moment because now we're down to this graphic and this graphic, which really goes down to is this an outlier or not. But I'm also seeing differences in this box plot. This one goes up to 12 and down to about 1. That's good. Okay. And this one over here does not go to 12. We have eliminated it. This one does not go to 12. Notice how the highest number is 12. This one goes to about 17. So the maximum in this data set here is 17, but that does not go with this plot. The maximum here is 12. Confirming once again for us that this picture right here, where the maximum value is 12 by the highest point, is this. Now, this is not the maximum right here. The maximum is that value, which is an outlier, which does even appear to be based on the 1.5, at least 1.5 IQRs above Q1. So that's kind of a visual solve on it, doing a little bit differently. Does that make sense right there? I think, was it Kevin was asking about this? Did my visual solve make sense? If you want, you can always copy to the clipboard, hit Command or Control C right here. And once you copy it, go over to Jump, do File, New, Data Table, and then do Paste with Column Names. Very important if it has column names like this had, to paste with the column names. So now you could go right here and finally go to Analyze Distribution. And with Analyze Distribution, you can double click both of them. Click, 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 click OK. And then last but not least, stack them. And I would go to Uniform Scale. So now you can see there is the outlier, and you can kind of get an idea of where this goes to. You could even zoom in to see that it goes up to 12, just to confirm. And we are changing the uniform scaling a little bit. But this would give you an idea that there is an outlier and give you an idea of how that looks like. And that is how to solve it with Jump. But we can also visually solve it. So at that point, we'd be narrowed down to this one or this one using the visual solve and Jump. But then visually speaking also, you can see that there is a whisker on region 2. So it really is like, okay, there is an outlier. That is an outlier. And then also we have the solve. For some reason, when I click on Analyze and Distribution, it won't let me see the quantiles table. Is your variable right here? Good question. Do you see, is this red or blue, Kevin, right there? Is that red or blue? Is this value right here red or blue? It's probably red, I'm thinking, right? Is it red? Tell me if it's red or blue, because I'm thinking it's red on your screen. It's red. Ah, good work right there, Kevin. 100 points. Don't worry that it's red. That means it's seeing it as categorical. So do this. Go to File, New, Data Table. Go to File, New, Data Table. Under File, New, Data Table, click Edit, and then Paste with Column Names. Don't click inside of it yet. Paste with Column Names. So go to Edit, and then tell me it should be blue now, and now you can do the Analyze Distribution. If it's red, it thinks that it's categorical and it's not doing the quantiles. It'll observe it as categories. So make sure to, for this data set, paste with the column names, which is not regular Control V. Like if you hit Control V, it just does a regular paste. Control Shift V on a PC does paste with column names. So you have to make sure you paste with the column names, which puts the column names at the top. Whereas opposed to if you don't paste with the column names, you get a categorical right here, which won't analyze properly. So this is an error that's commonly made where the data comes in as categorical and the wrong variable type. So variable types are big right here. Categorical will give you bar charts, where quantitative will give you histograms and give you the quantiles on the data. Did that fix it right there, Kevin? I hope. Maybe. We'll take a look at the remainder of the question. But those are just two ways to solve it, visually or with Jump. Both are very great ways to solve it and good practice to understand these concepts. So region 1 is more tightly clustered. Region 1 is unimodal, hence there's one modal area, peak around this mountaintop. Region 2 is, can you re-show the step? Oh yeah, we'll do it next. Is more bimodal, around the modes. The distances are fairly symmetric, and there is an outlier in region 2. That should do it. So let's show again the steps right here. Kevin, good questions. Go to File, I'll do it slowly right here. File, New, Data Table. File, New, Data Table. Under File, New Data Table, don't click inside of anything when it opens. So you want to have the new data table open, but don't click inside of it. Now you want to make sure also you have in your paste the data you're trying to paste in. If it had region names like you see over here on the left side, make sure you paste with column names. If it had like names above it, you'll see that when you open up the data, and we can show that right here. So if you had it, you'll click this button here. The way this looks when you're copying data is it would look like the following. When you copy to the clipboard, you will see a name up here at the top that is a column name. There might be other examples of other questions where there's not a column name. Some of the, I think that has column names too. Let's see if this has a column name. This one does have column names. That would need to paste it with column names. Try to find one here. If we can find one without column names to show what that looks like. It's just the ages. That doesn't have data. But we'll try to find one that doesn't have data. If it doesn't have column names, you will not see a column name at the top. If there are no column names, there will be no column name at the top. And we might not have one to show. And does that make sense, Kevin? That's a good question right there. We cannot find it. That is just the quartiles or the 5-number summary. This does have column names too. I think we just looked at this. That does have column names. So that needs to be pasted with column names. And yes, it does. Awesome. If it doesn't, oh no, we just did this one. So if it doesn't have column names, which I can find one that doesn't have a column name. Let me go grab it. If it doesn't have a column name, which some don't, they should. They should frankly always give you column names, and they'd have consistency, but I guess you have to see things that are a little bit different. When it doesn't have column names, it will look like, oh good, this data right here, copy to clipboard. This does not have a column name. So when I copy this data, I'd go to File, New Data Table, and then I'd go to Edit, Paste, because this did not have a column name. Notice how there was no column name, and so I would paste just normally. But if it does have a column name, make sure to paste with the column name right there. This probably doesn't have a column name. Copy to clipboard, no name of column up there. So that would be just pasted. Copy to clipboard, no column name, so don't paste with a column name. Maybe one of these will have a column name eventually, but double check if the data you're pasting in has a column name or does not have a column name. And that'll do it. Like this one right here, no column name, so regular paste with no column name. That's got it. Great work right there, Kevin and everybody. With that, it's time for the end of office hours. Kevin, great job. Let me know if you have any questions. We'll be back here later today doing more office hours. I'll see you then. Bye for now, everyone. Bye.